11.9 Representations of functions as power series. First, we're going to recall what a power series is. So from the previous section, power series is the series that are written in the form Cnxn, which is C0x0, where n runs from 0 to infinity, plus C1x1, C2x2, all the way. And in general, we can write it Cn x minus a. Some people put c there, some people put c instead of a. This is also can be written C0 x minus a to the 0 plus C1 x minus a to the first, etc. This is a power series where n goes from 0 to infinity. Power series centered at A. Centered at A. Or some people say about A. So that's what a power series is from the previous section. So here we recall that the sum of AR to the n, where this is an infinite geometric, the formula for the sum was A over 1 minus R, or A1, if you want to call it A1 over 1 minus R. This can work only if the absolute value of R is less than 1. So this was the sum of the infinite geometric series. Now, if we let A to be 1 and R to be X, just replace in the previous one, R equals X and A equals 1. So then that series that I wrote earlier, ARN, becomes 1x to the n, or x to the n, where n goes from 0 to infinity. That would be 1 plus x squared plus all the way forever, right? And this one would have a sum of A is 1 over 1 minus R is x. This can only work provided that the absolute value of x is less than 1. To apply this to an example, express the function f of x 1 over 1 plus 2x as a sum of a power series and find its interval of convergence. So I'm going to take this function and represent it as a power series. And later on today, we're going to learn why we're doing this. How does that help us in math? So this function that you see, the 1 over 1 plus 2x, I'm going to rewrite it in the form looks like this, 1 over 1 minus x, in that format. So I have the 1 as is over 1 minus, I can rewrite the 2x as negative 2x. See, now that looks like it's in that form, 1 over 1 minus x, right? So x here in this example up there, that's what we call R, the common ratio, right? We told you R is x. So here, this is like our R. R is negative 2x. So if I want to write it, I want to write it down. So earlier it was 1 plus x squared plus, so it's going to be 1 plus R is 2x plus 2x squared plus negative 2x cubed plus etc. Right? Provided that that R, which is negative 2x, the absolute value of that has to be less than 1. Then that equals the sum remember again I'm going to write it down here on the side. The 1 over 1 minus x is the sum of x to the n and goes from 0 to infinity. So if you want to rewrite what we just got using sigma notation, n goes from 0 to infinity, basically we put the r in there, which is negative 2x to the nth power. And it would be nice to rewrite this by breaking down into negative 1 times 2 times x to the n, which can be rewritten as negative 1 to an n times 2 to the n times x to the n. So that means that function they give us, this is the f of x, the 1 over 1 plus 2x. I was able to rewrite it using the sigma notation or power series representation. The problem has or the example has another part. The second part is about find the interval of convergence, right? So we know that the geometric series converges, like get a sum, if the absolute value of r is less than 1. Right, you can find the sum. And r, we told you r is negative 2x. So you can rewrite this with no negative because the absolute value will clean it up. And to solve such inequality, we drop the absolute value bigger than negative 1, less than 1, and divide by 2. So you get negative 1/2 less than x less than 1/2. So the interval of convergence is negative 1/2 to 1/2. Let's look at another example similar to this. Same thing, right? Let's call it g of x. 1 over 4 plus x. Write this or represent this as a power series. We present it as a power series. So we need, remember, we need to get it in the form 1 over 1 minus something. So I want to get 1 minus r, like that, right? In that form, to be able to use the geometric thing. So how do I get this in that form? Let me start with this one. I want to get 1 there. So how do I get 1? I factor a 4 out. That gives me 1 plus x over 4. And then after that, I can pull the 4 as 1/4 out, and I have it like this. Right? So the 1/4 doesn't do that much. Just keep it out. And then after the 1/4, we are going to write this as 1 minus negative x over 4. So this is my r, negative x over 4. So then we keep the 1/4 out. We go sigma, the sum, and goes from 0 to infinity of r to the n, right? R to the n. So r here is negative x over 4 to the n. I mean, that would be okay, but then it would be nice if you can simplify it by rewriting this 1/4 sum, negative 1 to an n, x to an n over 4 to an n. And you can move the 4 back in with the denominator, becomes 4 to the n plus 1. Again, n ranges from 0 to infinity. So that would be the power series representation for that function, 1 over 4 plus x. To find the interval of convergence, so we know the absolute value of r has to be less than 1. R is negative x over 4 less than 1. Then we could drop the negative, and then write the 4 down there, multiplying by 4, and then that gives me negative 4 less than x less than 4. That's the interval of convergence. So I'm going to take the same problem, but instead of 1 on the top, I'm going to put x squared on the top. Find the power series representation for h of x. So let's move on to this one. So how do we do this? This one, I would write it as x squared times 1 over 4 plus x. And notice, for this one, we already found the power series, the one we just got. If we scroll back up, it was negative 1 to an n, x to an n over 4 to the n plus 1. N ranges from 0 to infinity. And notice what is ranging, what's changing is n, not x. So you can multiply the x in to get the sum, negative 1 or n, x to the n plus 2 divided by 4 to the n plus 1. N goes from 0 to infinity. And because r stays the same, so r is the same, so the interval of convergence stays the same as before, the previous example. How about another example? 8 over 1 minus 4x squared. Write the power series representation of this function and find the interval of convergence. So this goes as, first I would write 8 times 1 over 1 minus 4x squared. I see I have a 1 here, so that's what matters the most. This means from here I can tell what r is. R is the 4x squared. So we go 8 times the sum of r to the n. R is the 4x squared to the n. N ranges from 0 to infinity. Then keep 8 out. Let's see. I can write this as 4 to the n times x to the 2n. And if you want to bring 8 inside, you can do so. Maybe you want to bring it as 2 to the third, and the 4 make it 2 square, becomes 2 to the n, x to the 2n. And then algebraically you can add the exponents there and keep everything else the same. Yes, find the radius of conversion. Remember, r has to be less than 1, absolute value. R is 4x squared, less than 1. So because we have an absolute value, is the same as if you just do 4x, then 4x less than 1, bigger than negative 1. Then divide everything by 4. So the interval of convergence would be negative 1/4 to 1/4. Let's go back over the interval of convergence. So here we know this works from the geometric series, right? So because the geometric series converges when the absolute value of r is less than 1. Then r here was 4x squared, right? So we substitute that in for 4x squared. Actually, that should be 2 here. 2, and then so the absolute value of 2x less than 1, that should be 2. And what happened is the 4x squared is kind of like, think about, you did like the square root or something both sides, right? You get 2x less than 1, and then you drop it that way. If that was like 8x squared, you do 2 square root of 2x. If there was 9x squared, you do 3x absolute value. Any questions about this? Yes. Next one, so far we covered this. 1 over 1 minus x is the sum of x to the n equals 0 to infinity. Remember here r is like x, right? R is like x. One thing about this sum, we could write it as x minus 0 to the n. X minus 0 to the n. And what we can do from this 1 over 1 minus x, we can rewrite this as 1 over 1 minus x minus 0. So this is the power series. That's how I start the section today. Is a power series centered at what? Power series centered at 0, right? Centered at 0. Power series centered at 0. Why do we need to know it this way? Because you can be asked to find a power series representation for the function f of x 1 over 1 minus x centered at -1 or centered about -1. Centered about -1 means if I look back at that 1 over 1 minus something, so this is how this is going to look like. So the 1 over 1 minus x, we need to rewrite it 1 over, it has to be centered at -1. So how does it work to be centered at -1? So this means 1 minus, instead of x, we needed x minus -1. Like that, x minus -1. That's what's centered at -1. X minus a or x minus c. So x minus -1. But if you do it this way, we're not allowed to do that, because what I just basically did, instead of x, I made it x plus 1. We can't do that. So to balance this, what we do, instead of just subtracting -1, we're going to add -1 as well. It's like completing the square. You subtract and add the same number. So then this can be rewritten as 1 minus x plus 1 stays the same, minus 1. Then multiply the negative in x plus 1 plus 1. So that makes it 1 over 2 minus x plus 1. Our r is the x plus 1 maybe, but wait a minute, how do we know it's x plus 1? Well, notice this number here is not 1 anymore, it's 2. So what I'm going to do, as we did in the previous examples, we pull the 2 out. That gives me 1 minus x plus 1 over 2. And that 2, we can pull it as 1/2, 1 over 1 minus x plus 1 over 2. Like so. Now I can see what r is. R is this highlighted part. So here R is the x plus 1 over 2. Keep the 1/2 out. Remember, it's always the sum and goes from 0 to infinity, r to the n. So x plus 1 over 2 to the n. And we can always do some rewriting. The top to the n, 1/2, 2 to the n. n goes from 0 to infinity. The bottom 2 to the n plus 1. Then, to find the interval of convergence, if required, we take the absolute value of r less than 1 because of the geometric series. And r is what? R is x plus 1 over 2, as we stated before. Then what? We have multiply both sides by 2, then x plus 1 less than 2 and bigger than negative 2, subtract 1, we can look at another example. Find the power series representation for the function f of x 1 over x centered at x equals 1. So we start with 1 over x. We need to rewrite it. I want to get it to have a 1 minus something. That's what I want to do, 1 minus something, right? So to do 1 minus something, I need a 1 inside because 1 minus 1 will cancel each other. And I need a minus x in there because when I distribute the negative n, I got the 1 on the left side back, right? So if you take this on the side and multiply it, you get this. So that gives me the function back. So this tells me this is my r now. R is 1 minus x. So it's going to be the sum and goes from 0 to infinity of r to the n. So 1 minus x to the n. This is the power series representation. If I want to find the interval of convergence, absolute value of r is less than 1. So 1 minus x, absolute value less than 1. And how do we solve things like this? 1 minus x less than 1, bigger than negative 1. Subtract 1. Multiply by negative. So that will make it 0 less than x less than 2. So the interval is 0 to 2. So now some operations with power series. Operations with power series. If we have two functions written as power series, as you can see, f of x and g of x. If I want to find f of kx, k could be any constant, simply you replace the x with kx and rewrite it. Not only that, but if we, from these two functions, we can add them or subtract them. That's allowed. So this f of x plus g of x is the sum and the difference of these two series. And what do we need this for? We're going to see some operations on that in a minute. If we are given these two functions, f and g, we are asked to find the interval of convergence for f of x plus or minus g of x. For f of x, the interval of convergence was negative 1 to 1, because you can tell that's a geometric series, right? And for g of x, the interval of convergence, if you run through, that's not a geometric series, g of x. It's not. If you take n0, n1, n2, write them down, you can tell it's not a geometric series. So what we do in that case, we can use ratio tests as we did in the previous section. So the interval of convergence will be -2 to 2. What matters to me now is how am I going to find the interval of convergence for the sum and the difference. So the way it works is that you take each one of them, the interval of convergence for the first one and the interval of convergence for the second one. So we take -1, 1 and -2, 2 and intersect them. So the upside down U means intersection. And what would be the intersection for these two is -1 to 1. So if you put that on the number line, let's say -1 to 1, and then you have another one -2 to 2. So the first one goes from here to here, and the other one goes from -2 to 2. So they intersect somewhere there, which is -1 to 1. So that would be the interval of convergence for both the sum and the difference. So why did we do the intersection? Intersection means what they share in common, the overlapping. So for the first one, again, it's -1 to 1 because geometric series. The other one, you could do ratio test. And we want values for x. That would work for both, right? For both, for the sum and the difference. And that's how it's done. If you remember when you guys solve inequalities, we call them compound inequalities. So that's what it is. So we need the intersection in math means this means and has to work for both the first one and the second one. Another thing good to see now, find the power series centered at 0 for such a function, and then after we finish that, and we need to find, add to this, find interval of convergence. Find interval of convergence. So what makes this looks totally different than the stuff we've done in the past is that before we had just x on the top, we could take it out, or just x squared, or 1, or 8, take it out. But here we have 3x minus 1. And not only that, we have like x squared minus 1 on the bottom. Of course, you can rewrite the denominator as you take a negative out, do 1 minus x squared. But that's not my goal here. My goal is I'm going to take this, factor the denominator, and do something that we've done it before. It's the partial fraction decomposition. So I'm going to rewrite this as a over the first one, b over the second one. And then I'm assuming everyone can solve to get a to be 1 and b to be 2. When you do the partial fraction, multiply everything by the least common denominator and solve. So then that fraction, or the 3x minus 1 over x squared minus 1, is a over that b over this. And now we can take these two fractions as two series in that sense and work each one separately. So we're going to look at the sum of this, right? Or if you don't want to put the sum, just this by itself. How do I get this? Remember, they are talking about centered at 0. Centered at 0, all I need to do is pull the negative out. That makes it 1 minus x. So this means it's centered at 0. X, just x means x minus 0. And this can be rewritten as -1 times 1 over 1 minus x. So then you get -1 times the sum x to the n, where n goes from 0 to infinity. And I usually like to put the -1 in times x to the n. N goes from 0 to infinity. So that's the power series representation for 1 over x minus 1. So the 2 over x plus 1, we can rewrite as 2 times 1 over 1 plus x, which can be rewritten as 1 over 1 minus -x. That's centered at 0. So now I can see it's a geometric series with r negative x. And then just move the 2 in. 2 times negative 1 to an n, x to an n. So here what we have for the first one, the r was x here, r was x. So then you can tell absolute value of r less than 1 for the interval, so x less than 1, so it's going to be negative 1 to 1 for the first one, for that one. For this one, r is negative x, so I'm going to do same thing, negative x less than 1. You could drop the absolute value, and then x would go from negative 1 to 1. So, or negative 1 to 1 like that. So now for their sum, because that's what I wanted to find. For their sum, I take the first interval, negative 1 to 1, and intersect it with the second interval, which will give me the same interval, right? Negative 1 to 1. So this would be the interval of convergence. Interval of convergence. For the given function f of x, which is 3x minus 1 over x squared minus 1. So here we have other applications. We talk about differentiation and integration of power series. So how do we differentiate and integrate power series? What do we use them for? Again, recall, f of x is Cn x minus a to the n. That's the power series centered at a. Okay. We have a theorem. The theorem about power series said the power series above, which is f of x, has radius from the previous section of convergence. We're going to call it r, bigger than 0. We can write f of x as c0 plus c1 x minus a. If you don't write it down, c2 x minus a squared is differentiable over the interval a minus r comma a plus r. Then two things can happen. So why a minus r, a plus r? Because if you put a as, you know how we said the power series centered at a, radius of convergence r means you go up plus r and down minus r. Think about like a circle like this. That's the interval convergence from a minus r to a plus r. So the first thing we get from this, what the theorem says, if we have a power series like this centered at a with radius of convergence capital R, then two things happen. The first one, from that f, we can differentiate f and get c0 will be gone because it's a constant. The derivative of c1 times x minus a is c1 plus the derivative of the second one, like that, and then derivative of the following one, 3c3 times x minus a to the square plus etc., which can be written, which can be rewritten as well, the f prime of x, as just, I'm going to write f of x on the side so to see it one more time. It's the sum of Cn, the one we wrote earlier, x minus a to the n. Right? That's f of x, plus like that. When I find the derivative for that, so this is what happened. You bring n down, right? Using n down, so ncn x minus a to the n minus 1, where n changes from 1 to infinity, no 0. So because the first term was dropped, so no n equals 0, n equals 1. So this is important stuff. Not only that, we could integrate f of x. We could integrate f of x dx to go as, this is how we do integrals with power series. We write the constant, you know how at the end you write plus c? We write it here at the beginning plus c. C plus, if I integrate my given series, the c0 x minus a is going to stay the same, plus c1 x minus a squared over 2, plus it goes on c2 x plus a to the third over 3, etc. And all of this can be rewritten as, using sigma notation, I have cn x minus a to the nth power plus 1, all divided by n plus 1. Where did that come from? Again, you could tell from here, you know, when you integrate the x minus a to the n, you add 1 divided by the same thing, n plus 1. So that's the integral of f of x dx.
Start from 0?
For the bounds, because we're not dropping the first term, so n starts at 0. So n starts at 0. Keep in mind two quick things to keep in mind. First one, when it's kind of like when you differentiate a sum of c0 x minus a to the n goes from 0 to infinity, you can differentiate the term inside that. When n goes from 0 to infinity. Another one, when you try to integrate the same sum, dx, you can integrate the term inside the sum, Cn. See, you don't drop any of the n's. I'm just telling you, you could rewrite it this way to be able to use it. We can look at an example, find a power series for this function centered at x equals 1. So it says centered at 1, right? Centered at 1. So you might need to think about, if this doesn't look like the standard form, 1 over 1 minus x, you want to think about either differentiating some function or integrating some function to help us with this. So to me, I would think about, what is ln of x? ln of x is the integral or antiderivative of 1 over x, right? 1 over x. So I want to think about, what can I do with 1 over x? Well, maybe I would start with 1 over x on the side, and they want it to be centered at 1. Centered at 1 is going to be 1 minus what should go in there? I need an x minus 1, right? So we want x minus 1 like that. But if I multiply it out, that's not going to work out. I need basically minus x plus 1, right? Minus x plus 1. Or again, you could rewrite as 1 minus negative what do we have here? Negative x minus 1. This is our r. This is our r. So I'm gonna find the power series representation for 1 over x, which we did earlier. So then this would be the sum of r, which is negative x minus 1 to the n, as n ranges from 0 to infinity. So that would give me negative 1 to an n, x minus 1 to an n. So now I can go back to my function g of x, ln of x, and integrate that, right? Integrate the sum, n goes from 0 to infinity, negative 1 to an n, x minus 1 to an n. And when we write that, make sure you put a parentheses and dx. So here is, we are going to pass the integral inside to integrate this. When we integrate this, n keeps starting at 0, and the integral of negative 1 over n is just negative 1 over n to the n power. That's a constant. But the integral of this is you add 1 divided by the same exponent, and don't forget the plus c that comes out. Okay, don't forget the plus c that goes outside. So, in summary, we have ln of x equal, we always write the plus c first, negative 1 to an n, x minus 1 to n plus 1 over n plus 1. N goes from 0 to infinity. This is the ln. And just for fun, if we let x equals 1 into this answer, what happens? What we get? ln of 1 is 0 equals c plus. All this sum, all that quantity is going to be 1 minus 1, 0. That the whole thing 0. So c is 0 when you set x equals 1 on both sides. So in this case, I can rewrite ln of x as the sum, n goes from 0 to infinity, negative 1 to an n, x minus 1 to n plus 1 divided by n plus 1. That's what ln of x is. And if you like to write it down, if take n equals 0, you're going to get x minus 1. Take n 1, you're going to get minus x minus 1 squared over 2. And then x minus 1 cubed over 3. X minus 1 to the 4th over 4, etc. This has a lot of applications for later on. Another example, find a power series for g of x, arctangent of x, centered at 0. Okay, so when I look at something like this, I'm taking a test or a quiz or trying to do a homework problem, they asked me about the power series representation. So when we started the section, we started with something like a function that I could rewrite to make it in the form 1 over 1 minus x. But such functions like natural log, arctan, other ones, is not, you can't do it this way. So then differentiation, integration comes to mind. I want to think about a function, if either I integrate or differentiate, it will give me arctangent. That's what happened to the previous example. I was thinking, is there a function if I differentiate gives me natural log of x? If not, is there a function if I integrate it gives me natural log of x? And then one thing came to mind is 1 over x. So when I integrate 1 over x, it gives me, natural log of x, right? So same thing with arctangent of x. Arctangent is there a function if I differentiate or integrate gives me arctan of x, right? If I differentiate something gives me, no, there's not easy to find. But if I integrate 1 over 1 plus x squared dx, that's the formula, that will give me the arctangent of x. Forgetting about the plus c for now, right? So then I'm gonna start thinking about 1 over 1 plus x squared. I can rewrite it as 1 over 1 minus negative x squared, right? Negative x squared. So this one, I can do the power series representation for this one so easily because now I know what r is. R is negative x squared. I can substitute that into the formula 1 over 1 minus negative x squared. Sorry, that should be r to the n, which is negative x squared to the n. And you could rewrite this as the sum negative 1 to an n, x to the 2n, where n ranges from 0 to infinity. That's the power series representation for 1 over 1 plus x squared, not arctan. And then to get to the arctan, we are going to integrate this, because the integral, so the arctan of x would be the integral of 1 over 1 plus x squared dx, which would be the integral of the sum dx, n ranges from 0 to infinity. And how does that work? It's, you have a constant plus. When we integrate that sum, as we learned before, keep the negative 1 to an n, this becomes 2n plus 1 divided by 2n plus 1. So that would be the power series representation for arctangent of x. And in some cases, as we did in the previous example, we may set x equal to 0 and see what happens. So if we set or let x equal 0, arctangent of 0 is 0 equals the quantity in the sum, that will all go to 0. So that will give me C0. So if I substitute it back in, then arctangent of x can be just simply rewritten as n goes from 0 to infinity of negative 1 to an n, x to 2n plus 1 over 2n plus 1. And if you like to, substitute n0, 1, 2, 3 to see how that's going to look like, then arctan of x would be, if you plug in 0 in for n, that would give us just x. If you plug in 1 for n, that's going to give us negative x cubed over 3. If you plug in 2 for x, it's going to give us x to the 5th over 5, then negative x to the 7 over 7, plus etc. That would be the arctangent. So the reason we're writing them all the way to the final step like so, because that will help with the next section when we talk about Maclaurin and Taylor polynomials or Maclaurin series. The next example we're gonna evaluate, try to find the integral of 1 over 1 plus x to the 5th dx. Integrate this. By hand is not gonna be easy to do, but as a power series. So such an integral is not easy to do by hand. But they are asking us, hey, try to integrate using power series. So try to use power series to help you integrate this. And the first thing we do is I'm gonna look at this function inside and rewrite it as a power series by doing 1 over 1 minus negative x to the 5th. That's what r is, negative x to the 5th. And when we go through this, we get the sum for this. That's what r is. R is negative x to the 5th to the nth power. That's the power series representation for that function, right? And then if you like to rewrite it, n goes from 0 to infinity, negative 1 to an n, x to 5n. That's what we get. So after we found the power series representation, we can differentiate both sides or integrate both sides. But since we're doing integral, we are going to integrate both sides. Dx equals the integral of all of this sum dx. Then sum n goes from 0 to infinity, the integral negative 1 to an n, x to the 5n dx. And then when we integrate something like this, we start with the c plus, keep the negative 1 to an n the same, x to the 5n plus 1 over 5n plus 1. And don't forget the sum. So that would be the answer to that integral as a power series.